You ever look at a bunch of code and just think, wow, that looks like magic? Well, I'm here to tell you, it's really not. Turns out, every single programming language, just like any language we speak, is this super structured system. It's got its own vocabulary, its own grammar, its own rules. So today, we're going to pull back that curtain and take a look at the hidden grammar of code.
All right, let's get into it. Here's the plan. We're going to start with the big picture ideas, the philosophies behind code. Then, we'll zoom in on the actual rules of the game, and then get down to the tiniest building blocks. After that, a quick history lesson, and then the big one, why any of this actually matters. So first up, let's talk about the core philosophies. And this might be surprising, but not all programming languages really think about problems in the same way. Each one is built around a specific idea, a paradigm, that kind of sets the worldview for how you build something. So what on earth is a paradigm? Honestly, just think of it like a blueprint for a city, right? You could have a city with a perfect grid system, all angles super organized, or you could have one with old, winding streets that grew organically over time. Both get you around, but their whole philosophy is totally different. A programming paradigm is exactly that. It's the blueprint that defines the style for how you build your code.
And this is where you can really see those different blueprints. Imperative is like a recipe. Do this first, then do this next, step by step, super direct. Then you've got object-oriented, which is a lot like building with Legos. You create these little self-contained objects that have their own stuff inside and know how to interact with other objects. Functional is totally different. It treats everything like a big math problem to be solved. And then there's logic, which is kind of like being a detective. You just give the computer the facts and the rules, and it figures out the answer for you. Pretty cool, right?
But here's the thing. No matter which philosophy, which blueprint a language uses, it still has to play by the rules. Just like in English, there's a right way and a wrong way to put a sentence together. And that brings us to two of the most important rules in the entire game: syntax and semantics.
Okay, let's break this down. It's actually pretty simple. Syntax is the grammar. It's all about putting the words and symbols in the right order, with the right punctuation, so the computer can even understand you. Semantics, though, that's the meaning. That's what your code actually does. You absolutely have to get both right for your program to work. And this is such a perfect way to think about it. This sentence, technically, follows the rules of English grammar. Adjectives, nouns, verb, the syntax is fine. But what does it mean? Absolutely nothing. It's nonsense. And this is exactly what happens in programming when you write code that's structured perfectly, but it just doesn't do what you think it's going to do. It's a classic it runs, but it's wrong problem.
All right, let's peel back one more layer of this onion. We've talked about the big philosophies and the grammar rules, but what about the actual words themselves? Well, every language is built from a basic vocabulary, and we call that its lexical structure.
Just think of these as the atoms of your code. You've got identifiers. Those are just the names you make up for things. Then there are keywords, which are the words the language keeps for itself, like if or while. Operators are your action symbols, like plus and minus. Separators are like the punctuation, parentheses, semicolons, that keep it all organized. And finally, literals. That's the actual data. The number 42, the text hello world. And the wild part is, every program in existence, no matter how huge, is just a combination of these 5 things.
So, where did all this stuff come from? I mean, these ideas, paradigms, syntax, all these little pieces, they didn't just pop into existence. They grew and evolved over decades as people got smarter and smarter about how to talk to computers. So let's do a quick flyby of that history.
So it all really gets going back in the 50s with these very specialized languages. You had Fortran for the scientists doing math and COBOL for the business world. But then, 1972, C comes along, and it is a total game changer. It was so powerful it became the foundation for pretty much everything. That really set the stage for the 90s, when that object-oriented idea we talked about, the Legos, just exploded with languages like Java and Python, giving us a much better way to handle these huge, complex programs we were starting to build. Okay, so we've torn programming languages down to their very core. But so what? Why did we go through all that? Why does understanding this hidden architecture actually make a difference for you? Well, this is the payoff. This is why it all matters. When you get this stuff, you stop just memorizing commands and you start actually speaking the language. You know which tool to use for which job. And the best part? Learning a new programming language becomes so much easier because you're not starting from zero. You're just learning a new dialect, a new set of vocabulary for concepts you already deeply understand.
So what we've seen is that code is so much more than just a list of instructions. It's this deep, rich system for communication. It has philosophies, it has grammar, it has a vocabulary. So the question I want to leave you with is this. Now that you know the rules of the game, what are you going to build?